In this question, what we have to find is the angle ACP, and we have been given that there are two sectors, ACP and BCP. So this is one sector, the ACP, BCP is the other sector, and there's a semicircle. So we have to find the angle ACP. So let's name the angle. Let's make it theta in radians. So which would mean this one would be pi minus theta in radians. And we also need to point out the radius. This radius is r, and this radius is r. BD is r out of 2. Because AC equals BC. AB has a midpoint C, so AC equals BC. Yeah, and the way I think we can do it is area of the sector ACP would be equal to the area of BCP plus the semicircle. So to write it, area of the sector, so if I may write it, area of the sector ACP would equal theta out of 2 times r square, and area of the sector BCP equals pi minus theta out of 2 times r square, and area of the semicircle equals pi, it is half the area of the circle, so I have to do pi out of 2 times r out of 2 whole square, and that gives me pi r square times 8. So I'm going to next equate these, because it says that segment CP splits the regions into two sections of equal area. So that would mean the area of the sector ACP, that equals the area of the sector BCP plus the semicircle. So I'm going to write it as theta out of 2 r square equals pi minus theta out of 2 times r square plus pi r square out of 8. So we can get rid of all the r squares, and we'll be left with theta out of 2 equals pi out of 2 minus theta out of 2 plus pi out of 8, and that would give theta equals pi out of 2 plus pi out of 8, and that would give 8. That's 4 pi plus pi, that gives 5 pi out of 8. Now this is in radians. I have to convert it to degrees, so I would write theta equals 5 times 180 out of 8, and that would give me 4 times 28. That would give me out of 2, and that is 0.5 degrees. That's my answer.